Suppose we're asked to find the domain of y equals 1 over x minus 2. Well, as a quick review, the domain of a function is the set of all the possible valid inputs for the function, or all the possible x values for which the function is defined. Here we're facing a function where our x variable is in the denominator of a fraction. Whenever we face a function like this, it's always useful to remember that the expression 1 over 0 is undefined. That is, if we ever see the expression 1 over 0, we don't know what that means in our mathematical system. We don't have any consistent definition for this value. So if we ever have, say, y equals 1 over 0, then that y value would be undefined. So if we can find an x value that when input into this equation yields y equals 1 over 0, then that x value would not be in the domain because then this function would be undefined. Or in other words, that x value wouldn't be a valid input. Let's consider that. When do we get y equals 1 over 0? What x input do we need? Well, it's really simple. It's when x minus 2 equals 0. So when x minus 2 equals 0. Or alternatively, you can write this as x equals 2. In other words, when we insert x equals 2 here, we get y equals 1 over 2 minus 2, x equals 2. And this simplifies to 1 over 0, but this is undefined. However, for any other x value that we input into this equation, we will get a valid y value. For instance, let's examine what happens when x equals 1. Well, at x equals 1, y equals 1 over 1 minus 2. 1 minus 2 is minus 1, so this simplifies to y equals 1 over minus 1. And this simplifies to minus 1. Now y equals minus 1, that is a defined point. The function is defined for the input x equals 1. Consequently, x equals 1 is part of the domain. If we were to substitute any real value apart from x equals 0 into this equation, we always get a real value for y. Consequently, we can state here that the domain of the function consists of all values of x except x equals 0. And the way we write that is x does not equal to 0. That's the domain of this function.